So this one is classified paper 6 topic light question. In question 2, some students are investigating the magnification produced by a converging lens. Magnification is refers to like what is a comparison of size of image when we compared with an object. We call that as a magnification. Like example, if we say the image was say 10 centimeter and the height of object was example 5 centimeter. So how many times the image is bigger than the object? So it's like twice. So we'll say the magnification will be 2. So magnification is a comparison like a ratio between size of image over size of object or height of image over height of object. They use apparatus, so you should learn this, especially because they can ask in a planning experiment to draw an experimental setup in which you are finding either a focal length or measuring distance. So what we have eliminated object, then usually we have like a specific shape is there normally in a form of a triangle. So the light can pass, and when it passes through a convex lens, inverted images form. So as a result example, if it was like this triangle, then on the screen it will form opposite inverted. And even without calculation, I can tell what will happen to size of image or size of object. You can see U is smaller, and when we measure V, according to this setup, V will be larger. So when I compare size of image with size of object, what will happen to image? It will be larger, equal, or smaller. When I compare the
Larger.
image will be larger because image distance from a lens is more. So image will be larger. Then what student did, a student sets the measurement U between the eliminated object, eliminated triangle, as you can see, as I mentioned, and real images are always inverted. So if the object was like this, the image will be upside down, inverted. But the size of the image, as the image distance from a lens is more, so it will be larger than the size of object. So a student measured the height of illuminated object, which was 1.5, and measure and record in a table 3.1 the height of image H1 on the screen. So H1 on the screen we have to record. So you have to use a scale or a ruler and measure this height. So example for you, if it is 3.8, you will write your answer according to what you get. And your answer right now will be different from the marking scheme as the paper size is not exactly same. So you should have like you will have a different answer. The marking scheme answer for this one is 4.5, but for us it is like example 3.8. Yeah, so we'll write 3.8 according to our paper size. The next part we need, so after doing this 3.8, then student measure the height and U and for 25, 35, 45, and for each value of a U, record in table 3.1 the value for magnification. How to get the magnification? It's height of image over height of object, where H naught is from A. So H naught is 1.5. So how to get the magnification? So this you got as 3.8. 3.80. So how to get a magnification? This will be 3.8 divided by 1.5. Same thing, 2.25 divided by 1.5. Use the screen annotation to complete these values. Use the screen annotation to complete the values. So first is 2.53, okay. Because how we are getting a magnification, as I mentioned, for paper 6, you don't have to memorize any formula. Height of image over height of object. That is the magnification. Height of image is 3.8 and object was 1.5. So you just divide all the values by 1.5. So 2.53, 1.50, 0.73. Next is 0.50. always try to write your answer in the same number of significant figure or decimal places. Like in all the values, if you were having two decimal, this should also be two decimal. So we'll just round off this 0.367 to 0.37. Then we have to plot these results for magnification on y-axis and u on x-axis. So magnification is on y-axis, and magnification does not have any unit, it's a ratio, and u is there on x-axis. Now, what are the values of u and m? I will copy. For example, for this one, I will use a answer from marking scheme to plot for u. U is 20, 25, 35, 45, 55. And magnification for u, it was like 2.53, but I'm using the values for marking scheme. So that is 3 for this one. This was 1.5. This is 0.73. This one is 0.50 and 0.37. These are the values for magnification. Now we have to plot these results on the grid. So as they did not mention, you should start from, and the values are for magnification, maximum is 3 and the minimum is 0.3. So we have to select a suitable scale for the magnification, like 10 boxes equals to 1, 2, 3, or I can have like 20 boxes equals to 1. So 20 boxes equals to 1, then another 20 equals to 2, and then 3. So it will fit in the scale. So this one is 1. So this one is 2. This one is 3. And then for u, which is it, don't forget to label the axis. Like label the axis, the quantity which you are plotting on that axis, and the unit of that quantity. Usually it's given like u is there, m does not have any unit, so no unit is given as it is a ratio, and u is on x-axis. So don't flip the axis. So example, 10 boxes equals to 10. So minimum value is 20 and the maximum is 55. So we should include. Now we plot the results when u is 20. When u is 20, m is 3. So when u is equals to 20, M is equals to 3. Then use 25. M is 1.5. No, it is not necessary you complete the marking. Even you write till 50, you write till 60, that is fine. It's not like the whole axis should be marked, it's fine. So 1, 2, 3, 4, 5. So this is 25 and I'm looking for 1.5. Maybe because of the screen, if maybe my mark point may be up or down, but the main idea is just to give. So this is 2, this will be 1.9, 1.8, 1.7, 6, and 1.5. So this will be 1.5. And then 35 and 73, 0.73. And this will be 0.1, because two boxes equals to 0.1, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.75. So this will be 0.73. 45 and 50 means 0.50. 45 and 0.1. This will be 0.1, 2, 0.1, 0.2, 0.3, 0.4, and 0.5. Then 55 for 20 boxes on y-axis, 20 boxes equals to 1. On x-axis, I select one box like 10 boxes equals to 10 or one box equal to 1. Here 20 boxes, so each box, two boxes equals to 0.1, 0.1. And then 55 and 0.73. So 51, 2, 3, 4, 5. 51, 2, 3, 4, 5, 55. And points. So this will be 0 0.1, 0 0.2, 0 0.3, 0 0.35. So 37 will be somewhat here. So this is a graph. And what it look like, you can see the pattern. It does not look like a straight line graph. It looks like a curve because the points, the pattern when you see. So when we just have to join those points. When you're drawing a graph, use thin lines and don't overwrite, like try to draw or draw a line one time. Don't overwrite or use thin lines whenever you're marking a position for the graph. So this is a graph between magnification and U. Then from your graph, determine the value of U when M is 1. So when M is equals to 1, we have to determine the value of U. So what we have to do, you have to show this on your graph. So what you will do, you will draw a line from when M is equals to 1. So when M is equals to 1, find the value of U. So it's coming out according to this second box is there. So 32. So we'll write that as 32. So according to your graph, you will mention that position. 32 centimeter. You have to show this on your graph, so you have to show like how you worked out. Then describe one difficulty that might be experienced when measuring a height of an image and how you improve. Look, when we are measuring a height of image, what is the difficulty here? For example, as an image is formed and you place a ruler here or a scale. So what might be the difficulty? When you try to measure the height, you will block the light. When you block the light, you won't be able to see the image on the screen. So what is the difficulty in measurement or measuring the size of the image? That while measuring a size of image, we might block the light. And the moment we block the light, the image will disappear. Because if we block the light on the screen, the light cannot reach, so the image won't appear. That is one difficulty in measuring the size of image. And how we can overcome this difficulty? So there are different ways to overcome this difficulty. You can have a screen which is having grids on it, markings on it, or a grid or lines on it. Because when a screen with a grid is there, you know, like one line represents how many centimeters, so you can easily read the scale. So you can use a screen with a grid. If I know, like example, one box is 1 centimeter. So this is 1 centimeter, 2 centimeter, three. So I will know that this is 3 centimeter. So you can use a screen with a grid. This is one thing. Or what else you can use? You can use a translucent screen. Translucent screen means, because if I measure the height from this side, I will block the light. So if I use a translucent screen, the back side of the screen will also be illuminated. So I can measure the height from the back side and it won't block the light. So it will be easy to measure. Or what else you can do? You can have a screen which is having a a screen is there which is having a scale stick to it. A ruler is there which is already stick to the screen. So you can just read it. Otherwise, if you have to place a scale or a ruler, then your body will block the light from the source and the image will disappear. So for these type of questions, the light experiment in which we want to measure the size of image or height of image. What is the one difficulty for this one? That like we might block the light, so image will not appear on the screen when measuring the height. And what we can do, we can use a screen with a grid or the lines, or use a translucent screen. You can also use a translucent screen. So the light will be blocked. And how we can improve? We can use a screen with grid or lines, or you can also mention use the translucent screen. Is it clear?
Yes, sir.
Then the next part, when setting up the apparatus, the student makes sure that the card of illuminated triangle, the lens and screen are all perpendicular to bench. Explain why this is an important precaution. Like he should have all of them perpendicular, not inclined. Like all should be perpendicular 90-degree to the surface. You can see the illuminated object is 90-degree, the lens is 90-degree, and the screen is also 90-degree. Otherwise, if it is not 90, like example, if it was slightly inclined, that what might happen, the image may not form on the screen, or it might form a blur image or not focus image. The main purpose of this is to obtain a sharp image on the screen. They all should be perpendicular. This is also one of the precautions we should take when doing this experiment, that why the all should be perpendicular to each other. But why this is important precaution? Because this precaution will ensure that the image is sharp and focused on the screen. So the sharp and the focus image should be there. With this precaution, we can have a sharp and a focus image.